Hello everyone. We are now going to begin a new lesson which is called gases, and the first topic in this lesson is going to be pressure. So we are going to learn about pressure, what is pressure and how we measure the pressure. You would need a calculator. This is how the assignment looks like. There are 13 conversions that I want you to do. Pressure is measured in many units. One of them is ATM, which represents atmosphere, kPa, kilopascals, torr, PSI, and mmHg, which is also called millimeters Hg. I have this little box here that converts everything to ATM. ATM is a standard unit for pressure. We are going to convert all these given values, what I've asked, into ATM. They will all be converted. I'll show you how to do that in a minute, but I want to just talk about the word pressure. What does it mean and how does it relate to our real life? So here I want to talk about ATM, also known as atmospheric pressure, ATM, atmospheric. It comes from the word atmosphere. So here you see a mountain, a sea level, and then all these clouds and the air. Do you see the particles around here are more dense and more together, whereas as we go higher altitudes, the air particles are very less. What that means is that the air that is around us that we are breathing in, oxygen, carbon dioxide, hydrogen, helium, and all the gases around us are more concentrated at the sea level. And as you go up higher and higher, the amount of gas around you would be less and the concentration is less. So higher altitudes have lower air pressure. So because of these number of particles, you feel the pressure, and that pressure is known as atmospheric pressure. As you go high, you feel low pressure. As you go towards the sea level, you feel a lot compressed or pressurized. Um, Low altitudes, altitude means height, have low have higher pressures. So sea level is known as 1 atmosphere. This is the value 1. If you are at the sea level at the beach, you are feeling 1 atmospheric pressure. There are many apps that you can download. They will tell you the current pressure of your location. So this is about air pressure. I'll show you more examples. You see this three different bottles. These pictures are taken at different heights from the sea level. The first picture is at a very high altitude or a height which is 14,000 feet above sea level. The bottle was compressed and the lid was closed. You can see that the bottle is in the right size. Now the next picture was taken of a bottle. There is vacuum inside the bottle. There is no air. So the outside air is trying to crush the bottle. This picture was taken at 9,000 feet from the sea level. And the last picture was taken at the height of the sea level. And actually 1,000 feet above the sea level, and you see the air has crushed this bottle. The air that was outside has crushed the bottle. So this is the one effect that you can actually see what heights do to the air pressure. So the lower the grounded you are towards the sea level, you feel more pressure. And as you go towards the higher altitudes and mountains and hills, you feel lightheadedness and you feel less pressure around you. And now I want to show you how you remember, how you get the air in your tires. Look at the units in which you measure the numbers. So the front and the rear kPa, this represents kilopascals. Bar is another unit. PSI is what you normally see on a tag next to the car, which tells you the air pressure. The 33, 32 PSI, that's what the machines that are outside that fill the air in your tires, they use this unit. PSI. This is a picture taken from the car, and you see they are using kilopascals. as one of the units to measure the tire pressure. Okay, so pressure is where is very important for the tires. Then you have also heard about the blood pressure. So look at the units, focus on the units. This is the normal blood pressure, which is less than 120, the upper value, which is in mmHg, which is millimeters of mercury. Hg is the element on the periodic table, also known as mercury. And the lower value of the blood pressure is measured in is 80 mmHg, which is a normal value. If you have high blood pressure problems, they go up 120 to 129 millimeters mercury, less than 80 millimeters mercury. And this is hypertension higher than 180, the higher value millimeters of mercury. So the units are very important. In many cases, millimeters mercury, mmHg, is very commonly used, especially in medical terms. Now let's get to the assignment and let's start working on the problems. So this is a value 105.3 kPa, which has to be converted into atmosphere. And here I see in kPa, this is the conversion value 101.3. So basically you are dividing the given question value by the constant 101.3, that will give you the answer in ATM, because you are going to convert all these values in ATM. Millimeters of mercury, so you will divide this value. What is the conversion here? 760. So you will divide the given question value by the constant that's given. That would give you the answer in ATM. Here it's kilopascals again. So what you did in part A, you divide by the constant 101.3. Here you divide by 101.3 and you will get the answer in ATM. Remember, the constant should be the second value you put in the calculator. So the question value, which is 105, goes first, and the constant, that value goes second in the calculator. Let me show you one PSI. I hope I have an example over here. I don't, but if I add another example in the question, then you are going to divide the question value, the one that I will give you, by the constant. The constant is 14.7 PSI. All these constants equal to 1 ATM. That's why when you divide by these constants, they give you the answer in ATM, which is atmosphere. I hope that helps, but in case you need more help with this assignment, we will have Google meetings. Please message me and let me know. Good luck, and I will give you around a week to finish this assignment. All right, guys, take care. Bye.